Hello friends, myself Dr. Divya Gildial in continuation with my lectures for AKTU Engineering Physics syllabus. Now today I will be teaching you in electromagnetic theory two very important and lengthy derivations for your syllabus. Last lecture I taught you about pointing theorem and pointing vector, in which I told you lot of numericals are asked. Today, plane electromagnetic waves in vacuum and their transverse nature, relation between electric and magnetic fields of an electromagnetic wave. So let us begin with our lecture today. Now, plane electromagnetic waves in free space. See, first you understand what is meant by this term free space. Free space means no charges are present around it. That means the charge density is zero. Obviously, if no charges are present, then current density itself will become zero. Conductivity will become zero, permittivity and permeability will become zero. Electric displacement vector has value epsilon naught E and magnetic field is mu naught H. So we are taking the condition of free space, means no charges present, totally chargeless place, which is known as free space. So in case of free space, what happens is that a region which is having no gravitational and electromagnetic fields. Electromagnetic means no field due to electric current and no field due to magnetic effects or any magnet nearby, used as an absolute standard of free space. You can also call it as vacuum of free space. So in free space, your rho becomes zero, that is charge density, J, current density, I upon A, sigma 0, mu 1, epsilon 1, D equal to epsilon naught E, and mu B equal to mu naught H. You have to remember these expressions because you will be putting these values in Maxwell equation to derive an expression for plane electromagnetic wave in free space and prove that they are transverse in nature. That means that the electric field and magnetic field are perpendicular to each other and perpendicular to the velocity of light. So this is very important. Rho equal to 0, J equal to 0, sigma 0, mu equal to 1. Now, epsilon naught and mu naught are what are, let me tell you what is meant by what I meant by these symbols. Though I have told in my previous lecture, I will repeat them here once again for you. Epsilon naught, mu naught are electric permittivity and magnetic permeability of free space. Electric displacement is denoted by capital D. It is the charge per unit area that will be displaced across a layer of conductor that is placed across an electric field. It is also known as the electric flux density. J is electric current density, rho once again charge density, and permittivity also called as electric permittivity and permeability. Now let us start the derivation. This is a very lengthy derivation. So we go back to our Maxwell's equations. In our first equation of Maxwell, which was divergence D equal to rho, for free space, we will put rho equal to 0 in this expression. So it becomes divergence D equal to 0. For second equation of Maxwell, which is Gauss law of magnetostatics, divergence D equal to 0. Third equation of Maxwell, E equal to minus del phi by del T, which is Faraday's law of electromagnetic induction, and our modified form of Ampere's circuital law, in which in Maxwell it was curl H equal to J plus del D by del T. Now we have put J equal to 0. Now, how are we going to find out the expression? Students, this is a very lengthy mathematical derivation. So please, you will need to know few more formulas. In my derivation here, I have written them in bracket. You can take a printout first of this from the link which is given below in the description box, and then follow me step by step, because this derivation is very lengthy. Taking curl of equation 3. Equation 3 was what? Faraday's law of electromagnetic induction. So we are going to take curl of equation 3 and see curl E is equal to minus del by del T, curl B equal to minus del. Now in B here, we have put epsilon mu naught H, which is the another form of BC. Here, B is here we have put mu naught H, this value, mu naught H. And now we have taken mu naught outside here, common, and this becomes mu naught del by del T curl H. Now, putting this value of curl H from equation 4, here, equation 4 in equation 5. We will put the value of curl H and use D equal to epsilon naught E. We get curl E equal to minus mu naught here, del by del T here, and instead of curl H from here, del by del T. So this becomes minus mu naught del by del T, del epsilon, and now for D, we have put epsilon naught E divided by del T. So this becomes mu naught, and epsilon naught is also a constant. I have taken it outside, minus mu naught epsilon naught del 2E by del T2. You can again see it step by step how I came to this expression. Lot of derivation, formulas, symbols have to be first written in a rough register before you start this lengthy derivation. Okay, now this is equation 6. Next step, from the very famous mathematical vector identity, curl of E is equal to gradient divergence E minus del 2E. See, this is a formula of mathematics in vector calculus. It has got nothing to do with you deriving it. So you just have to memorize it. Now we will use curl E equal to gradient divergence E minus del 2E. And in this expression, which we just derived above, I will write, instead of curl E, gradient divergence E minus del 2E is equal to mu naught epsilon naught del 2E by del T2. Okay, from equation 1, for free space, divergence D is equal to 0, or and D is epsilon naught E. So what we have done is that gradient divergence E, this quantity, it will become 0. Why will it become 0? Because see, divergence D is 0 and D is epsilon naught E. So if I write here divergence D equal to 0, because divergence D is 0 and D is epsilon naught E. So gradient of divergence E becomes equal to 0. That means this quantity becomes equal to 0. So what are we left with now? Minus del 2E equal to minus mu naught epsilon naught del 2E by del T2. This is an important expression often asked in your AKTU paper. You will have to memorize step by step how I taught you to derive this expression using mathematical vector analysis and a few basic theorems. Okay. Similarly, this is for the electric field. For magnetic field, the expression becomes minus mu naught epsilon naught del 2H by del T2. You do not need to derive this again for your AKTU paper. So these two equations are known as wave equations for electric and magnetic fields in free space. They are important, often asked in section C of your paper. Derive the wave equations for electric and magnetic fields in free space. What is basically a wave equation, or how do you write it in a general form? We will compare this electric and magnetic field equation with our very general equation of waveform and find an expression for velocity of light. So wave equation is a linear second order partial differential equation which describes the propagation of oscillations at a fixed speed in some quantity u, where v is velocity of the wave. So this is a general equation of wave equation. This is general wave equation, and its definition I have written here. Wave equation is a linear second order, second order del 2 by del T2 partial differential equation, del 2u by del T2. This is describing the propagation of oscillations at a fixed speed in some quantity. You can take any hypothetical quantity here. I have taken u, and v is velocity of wave. In our case, we are studying electromagnetic wave, and we know that it travels with velocity of light, that is 3 into 10 to the power of 8 meter per second. Now, what are we doing? We are going to compare this general form of wave equation, this general form, that is del 2u equal to 1 upon v square or c square del 2u by del T2. This we are going to compare with this equation and this equation. See, we will compare. So you see del 2e or del 2u or double differentiation, and del 2h with this. We have done the comparison. So when we are comparing, this quantity 1 upon v square comes out as mu naught epsilon naught, and v in case of electromagnetic wave we know is equal to c, or velocity of light. So 1 upon v square becomes equal to mu naught epsilon naught here. We have just compared these equations because from the general form of wave equation, and we have come out to a very important derivation for velocity of light, that is c equal to 1 upon under root mu naught epsilon naught. This expression is asked a lot in your section C AKTU paper, that derive an expression for velocity of light in free space in terms of mu naught and epsilon naught. So C is equal to 1 upon mu naught epsilon naught. Very important expression, its derivation. You can check by putting the value of mu naught and epsilon naught mathematically also. It turns out as approximately 3 into 10 to the power of 8. So these two derivations which you just heard from me and did with me today are very important and very lengthy. Please first take the printout and then do them accordingly. Okay. Electromagnetic waves are transverse in nature. Waves are of two types, longitudinal and transverse. The longitudinal ones consist of crest and trough, whereas the longitudinal wave consist of compression and rarefaction, and the transverse ones consist of crest and trough. So the transverse wave motion, in which all points on the wave oscillate along paths at right angles to the direction of the wave's advance, are said to be transverse in nature. That means oscillate along paths at right angles. Right angle means 90 degree. Now you recollect what did I tell you in my previous lecture regarding EMT wave? This is my electric field vector and this is my magnetic field vector. They both are traveling perpendicular to each other, and these two are traveling perpendicular to the velocity of light. So obviously they will be labeled as transverse wave because the components are traveling perpendicular to each other. Now, in your AK2U exam, mathematically you are asked to prove or show that electromagnetic waves are transverse in nature. Again, let me tell you, it is a lengthy derivation involving lots of tips and tricks. Hence, please keep a printout of this ready on your study table and I can proceed further to explain you transverse wave. See, this is a transverse wave. It is consisting of crest and trough, amplitude, wavelength, etc. All other properties of wave. So in electromagnetic wave, electric and magnetic fields are perpendicular to each other and at the same time perpendicular to the direction of propagation of wave. This nature of electromagnetic wave is known as transverse nature. Now, in order to derive and mathematically show it, we will once again use our very derivation which we did right now for electric field, magnetic field, and any arbitrary solution for a wave equation. Del 2E minus 1 upon c square, del 2E by del T2 equal to 0, del 2H minus 1 upon c square, del 2H by del T square equal to 0, and del square U equal to 1 upon c square, del 2U by del T2 equal to 0. You don't have to show the derivation here, but the plane wave solution in general takes this form for electric field, magnetic field, and any arbitrary equation from which we are going to do the comparison. Now you note here in this expression, we have found the solution as a complex form, E equal to ik dot r minus I omega t. K is your wave vector, omega is the angular frequency, and because of this I, it becomes equal to sum of real and imaginary components. So see, E naught, H naught, U naught are complex amplitudes. Complex word means consisting of the real part plus imaginary part, cos theta plus I sin theta. And they are constants in space and time. K is a wave propagation vector. Mathematically, K is equal to 2 pi by lambda. Lambda, you can also write this as V is equal to F into lambda. So instead of lambda, I have written C upon F, or because EMT wave is traveling with velocity of light. So instead of V here, I have put C. 2 pi F is your angular frequency, which can be written as omega, and instead of VC. So this is your wave vector K, and these are the different forms of writing it. You will need this right now for derivation, which you are just going to study. So please once again see, wave vector K is 2 pi by lambda. V is equal to F into lambda. So instead of lambda, I have put V upon F, V for electromagnetic wave is equal to speed of light, and 2 pi f is angular frequency. That is omega equal to 2 pi f. Now let me proceed further, where n is unit vector in the direction of propagation, wave propagation. Before applying del dot E equal to 0 and del dot H equal to 0, we will find an expression for del dot E and del dot H. Okay. Let me first introduce, though you must be familiar with the symbol del, again let me tell you, mathematically del is taken in the three-dimensional form. So del is I del by del x, j del by del y, plus k del by del z. This is for the three-dimensional form. You are writing del. And E, right now above I showed you, equal to E naught e to the power of I dot k dot r minus I omega t. Similarly, you will be writing right now for H and U. Now we are opening this expression. Instead of E naught here, I will write it in the three-dimensional form as I, J and K. Similarly, here E to the power of I, K dot R. Instead of that, I will write it in vector form as Kx, X, Ky, Y, Kz, Z minus I omega t. See, this is looking a bit scary, but please do not worry. Just keep following it step by step. What actually I have done here in this expression is that I am trying to write it in 3D form or the vector form, where my components are X, Y, and Z. And I am writing it as the sum of the real part and imaginary part. That is all what we are doing here. Now solving it further. K dot R. How did I get this? Kxx, Kyy, and Kzz. See, K, I can write I, Kx, J, Ky, plus K, Kz. And R is I dot X plus J dot Y plus Kz. This, if you remember, across the I, J, K. And now dot product. I dot I is 1, J dot J is 1, K dot K is 1. So this comes out as Kxx, Kyy, Kzz here, this expression. Now we will proceed with the next step. We are going to open it and multiply this value here, here, and here. Why are we doing all this? We are doing all this to prove that the electromagnetic waves are transverse in nature. For proving this, what exactly we are doing is that we will show that the dot product for the electric field and magnetic field is turning out as 0. Hence, it is proved that electromagnetic waves are transverse in nature. Next step. Now we have opened it, put this value here. We know from mathematically that d by dx of e to the power of ix is equal to I e to the power of ix. Putting all these step values here, which we have derived, the expression takes the form del dot E equal to E naught x I dot kx plus E naught y I dot ky, E naught z, I kz, and this. Now, once again, we use this expression which we just derived above, and it reduces to this form. So, del dot E becomes equal to I dot k dot E. Similarly, it becomes for the magnetic field. Now, if you look here at this expression very carefully, del dot E and del dot H is equal to I dot K dot E and I K H. Requirement that del dot E becomes equal to 0 and del dot H becomes equal to 0 demands that K dot E equal to 0 and K dot H equal to 0, which proves that electromagnetic waves, the electric field vector and the magnetic field vector, both are perpendicular to the direction of wave propagation vector K. This proves that the electromagnetic waves are transverse in nature. Also, you can write it in another form. This is useful for your numerical point of view. This is just another form of writing it and proving that the electric and magnetic field vectors are perpendicular to each other and perpendicular to the direction of wave vector K. Here is the diagram. See, electric field, magnetic field, and direction of wave vector K. All three are traveling perpendicular to each other. Last, wave impedance of an electromagnetic wave is the ratio of the transverse components of your electric and magnetic fields. The transverse components are those that are at right angles to the direction of propagation. So Z is E naught H equal to mu naught C under root mu naught epsilon naught. This is just one derivation which you will be requiring for numericals. So a quick recap, what did we do today in today's lecture? Fast, we will just revise it, that electromagnetic waves are transverse in nature. They travel with speed of light. The electric field, magnetic field are traveling perpendicular to each other and perpendicular to the component of wave vector, and velocity of light c is given by under root 1 upon mu naught epsilon naught. Thank you.